Bernoulli's principle. In this module, you will learn about Bernoulli's principle and its examples. You might have noticed that in games like golf or cricket, a spinning ball deviates from its parabolic trajectory as it moves through air. Now the question arises, why a spinning ball changes the track when it spins? The answer to this question can be answered by learning about Bernoulli's principle. Bernoulli's principle, given by Daniel Bernoulli, is an energy conservation principle and states that for the streamlined flow of an ideal fluid, total energy, that is, the sum of pressure energy per unit volume, kinetic energy per unit volume, and the potential energy per unit volume, remains a constant. Let us now prove Bernoulli's principle. Let's calculate the named energies separately. From equation of continuity, velocity is high for a region of less cross-sectional area. Thus, the velocity at point B is greater than velocity at point A. Increase in kinetic energy from point A to B is given as half of mv2 square minus half of mv1 square. The increase in potential energy from point A to B is given as mgh2 minus mgh1. According to work energy principle, work done per second by the pressure energy is equal to sum of increase in potential energy and increase in kinetic energy, which on solving gives P plus half rho V square plus rho GH is equal to a constant. This equation proves Bernoulli's principle. If the liquid flowing through a horizontal tube, that is, the two ends of the tube are at the same level, the Bernoulli's equation reduces to P plus half rho V square is equal to a constant. Therefore, Bernoulli's principle also states that in the streamlined flow of an ideal fluid through a horizontal tube, the pressure increases where velocity decreases and vice versa. Now that you've learnt about Bernoulli's principle, let us try to answer why a spinning ball deviates from its parabolic path. As the spinning ball moves through the air, the direction of ball spin opposes the direction of airflow above the ball, whereas spin is in the direction of airflow below the ball. Thus, the velocity of air below the ball is greater than that above it. Due to this, the streamlines get crowded below the ball. Many day-to-day observations can be explained using Bernoulli's principle. You must have heard that during windstorms, the roof of a hut is blown off without damaging other parts of the hut. The wind blowing with very high velocity over the roof creates low pressure on top than under the roof. This pressure difference provides a vertical lift to the roof and it blows off with the wind against the gravitational pull. Bernoulli's principle also explains the reason for heart attack. The artery gets constricted due to the accumulation of plaque on its inner walls. The blood flows through this constriction with high speed, lowering the pressure inside. The artery may collapse due to the external pressure. The heart exerts further pressure on the blocked artery and forces the blood through it. As the blood rushes through the opening with increased speed, the internal pressure once again drops leading to a repeat collapse. This might lead to a heart attack. Two ships sailing in an ocean in the same direction, when come close to each other, get pulled towards each other. Let us try to understand why this happens. The velocity of water between the two boats becomes very large as compared to the velocity of water on the other sides of the boats, thereby decreasing the pressure in between the boats. The boats get pulled towards each other due to higher outward pressure. A person getting pulled towards a fast-moving train can be explained using the same reason. Let's summarize what you have learned in this module. Bernoulli's principle is an energy conservation principle according to which the sum of pressure energy per unit volume, kinetic energy per unit volume, and the potential energy per unit volume remains a constant for a streamlined flow of an ideal fluid. Bernoulli's principle also states that in the streamlined flow of an ideal fluid through a horizontal tube, the pressure increases where velocity decreases and vice versa. Bernoulli's principle is applied in the following situations. A spinning ball deviates from its parabolic trajectory as it moves through the air. During windstorms, the roof of a hut is blown off without damaging other parts of the hut. Blood flowing through constricted arteries results in a heart attack. Two ships sailing in an ocean in the same direction get pulled towards each other as they come close to each other.